Okay, Astrid, you can stay up here with me. I will thank you very much. Congratulations.
Thank you.
Congratulations. All right, do you need this for just a moment? Okay, Astrid is staying up here because actually we're going to go right into the next presentation, which still involves Schaeffler, because they are leaning into robotics, clearly, and doing lots of interesting innovation around it. Now, to join Astrid on stage, we have Minas from Acumino as well, who I think is around here because he's got a very cool setup as part of this presentation. He'll come in a minute. Okay, Astrid will tell us how it all works. I will then let you have the stage to tell us about this partnership, a little bit different from the last one. We're ready. Thank you, Astrid.
Thank you very much. So, isn't that inspiring how our future will look like? I personally am also very proud and curious what these robots can do in the future. We see them boxing, we see them dancing, we see them doing a somersault even. But to be honest, we've been talking a lot about physical AI today as well, and I have two issues with those videos. The first, none of those is giving industry an ROI yet. And the second, I hardly believe that what we see in those videos is really physical intelligent now. Maybe even more teleoperated or hard-coded. So what we show you today is physical AI at scale. We've heard that a couple of times today. And of course, in production, where we want to gain an ROI. And Schaeffler is not doing that alone. We hardly believe in collaboration and startups, so I'm not here alone on stage. With me is Minas from Acumino, and very proud
Hello,
we can do that together. Before we dig deeper, one minor overview, I would say. In those videos we've seen, they've been trained from somersaults or whatever we see in everyday life, so we have data. But as Raf also said, to make physical intelligence possible, we need this real-world data. So, as sending a child to school, having no book, having no teacher, you can't make physical intelligence bring it to life. So what you need to do is, you need to have data acquisition, you need to have training on that before you can deploy that to a robot. And this is exactly where Schaeffler is coming into play, because we have that kind of real-world data, of course, we want to utilize. And this is what we want to utilize not only for our plans, but also far beyond. And the point I want to reach out here or point out is, this is what we need to elaborate to really bring it to life. And how we do that, maybe Minas, you can comment, because
Absolutely.
This is how it works.
Yeah, thank you so much, Astrid. Thank you so much for joining us, for having us, and happy anniversary to Startup Autobahn. So you see here that we focus on a very, very complex problem. What is the complex problem? Complex packaging. How you get a box that is completely flat, you form it, you put different automotive parts inside, and then you close the lid in order to send it down the product line. And the focus is to collect the data for the robot with the human in the loop. Because the humans have the experience in the factory, right? The humans have spent 30, 20, 25 years doing the job. So humans collect the data being in the loop, exploiting the human intelligence, the human expertise, and then we transfer to the robot. And the robot can be an embodiment that is not necessarily a humanoid. It can be a bimanual manipulation system, because what is a humanoid? A humanoid is the sum of its parts, and the most important parts are the arms and the hands, right? Not really the legs, as the humanoid team said. So, human skills that get transferred very, very quickly, scalably, cost-efficiently to robotic skills.
That's very interesting, and I think, you know, in a production we have very different robotics we use today. Do you think hardware-agnostic is very important to that?
Absolutely. You need to be hardware-agnostic because you don't have a clue who will win. What humanoid company will win? What robotics company will win? manufacturers from Europe, from United States, from China. You cannot plan for a specific hardware in mind. You need to have a technology that can be used with any kind of hardware, any kind of robot arm. KUKA, Yoskawa, Fanuc, Mitsubishi, UR. Or humanoids.
Yeah, so I also believe that, so let's nail it down. Do you think everyone can do that, or is it special to Acumino? You have here some IP about...
I believe that physical AI is a very, very difficult problem. That's why we see a lot of capital flowing into physical AI. But I believe also that data is the most important missing piece. Because LLMs, ChatGPT, and all the other models that we know, they rely on the internet. They rely on the corpus that we have developed over decades, over millennia of human existence, right? Robots have exactly zero corpus. We don't have data. We started collecting data 4 years ago. We are talking about millions of trajectories. We need to talk about trillions of trajectories. So data is king.
Data is key, and I think you also have some really IP behind that, because you have patented
We have the patents for how you collect human-in-the-loop data. A lot of people, they have started stepping on our toes, but for us it's funny, because we started the whole thing 4 years ago, and now the software has been built from day one based on this technology that nobody believed 4 years ago, human-in-the-loop data collection.
So maybe one more sentence from yours concerning what's the difference in your AI models to maybe those big foundation VLA models?
I don't believe in big foundation models, and let me explain to you why. Because in the history of AI, you always have generalization capability and reliability. You cannot have both. You go for generalization capability, you compromise reliability. I truly believe, and this is the plan of Acumino, that we need to deploy smaller, task-specific, industry vertical-specific models that are super reliable, that we can use today to unlock ROI.
All right, so I'll have a last point before we move on. What makes Acumino to me also very specific is that we follow up a decentralized approach. Because we heard that also today, if you do that from central point, you will create a bottleneck. But here we have the chance to really enable our plans to really speed up that into scale fast. And we need to look at the time a little bit, so maybe just to give you a more insight on what we are talking, because we said we are doing that into scale in production. You've seen that boxes already. So this is a working center or a place in one of our plants, which is quite typical. A worker is folding a box, it's done manually. So we have plenty of those stations, and I doubt that this is something only for Schaeffler. You will find this boxing and kitting processes all around the globe. And only this working station has 16 million kits a year, and there are very, very many variants. And with conventional technology, it's impossible to automate that today. But now what we did today already is we automated it with your technology. We're on the road. So in August, it's all the way done. Maybe 2 things or 2 words quickly, but because we also have to step into that demonstration.
Absolutely.
Where we deep dive.
I will tell you what is next for this while I'm setting up for the demonstration. So the whole idea is that we need to roll this out not only in one station, but in many, many stations across one particular factory in order to show scalability. And then to see how this transfers to other factories, across locations, across continents, across production facilities. This is what physical AI needs, true scalability. And I hope that you are not using your mobile phones, because I will need the Wi-Fi. So let's see.
Oh.
Excellent. Can you switch to my screen, please? They have a problem with the video input. One moment, we'll wait for the technician. How much time do we have? 50 seconds. Okay, I have done more difficult things. Let's see. So what I'm doing right now, I am wearing an augmented reality interface that will allow you to see the production facility of Schaeffler projected on stage. Because we couldn't bring Halle with us, we have augmented reality Halle, and we start the robots, and I will go around in order to show you how this deployment will look like. You see here universal robots, but they can be also other robots. It can be completely hardware agnostic, the technology. This is the packaging, the complex box that we have folded, and this is an example of an automotive part that we need to identify with the camera, pick up, and put inside the box. Now, I am not demonstrating the folding of the box for the simple reason because we have the sim-to-real gap. And simulation is not ready to demonstrate the complex physics of folding a box. But you can appreciate how this station will look like and what we are trying to scale, what we are scaling together with Schaeffler. Thank you so much. And Astrid, back to you.
I only have one last slide, and I now click that through. Also, this story, as we had it before, the story with Schaeffler and Humanoid started right here, Startup Autobahn, and we just briefly wanted to acknowledge that. We started actually in February with such a deep dive. We called it Intelligent Shop Floor for the Future because we really look into our technologies in a strategic way. There, afterwards, we had last year the Innovation Award here. And of course, what you've seen a glimpse of that is in demonstration and also that setup we have in our real plan now, and we're gonna scale that quickly now. And something maybe you wanna announce?
Yeah, I'm super glad that I have recently announced last week that we raised a new seed round. Schaeffler is one of the corporations that participated in this new seed round, so welcome to the family of Acumino. And we look forward to strengthening the collaboration with Schaeffler and proving that physical AI can really scale.
We're also glad, and last word to Startup Autobahn, nothing of that would have been done with you, so thank you very much.
Thank you. Thank you, guys.